Welcome, everyone, to this World Resources webinar entitled Internet of Things. We're happy that you can join us on this Saturday. It's June 15th, and we have a lineup of exciting speakers, all experts in their areas, who will enlighten us on the benefits and uses and how we can maximize IoT applications for success, increase in productivity, efficiency, quality. And so we have a very exciting agenda planned for you. I will ask that once we start the presentations that you mute your mics and webcams to avoid the distractions. If you have your mics open, sometimes there's feedback and it's distracting to the rest of the audience. So I will appreciate your cooperation. I am Debra Ferdinand James. I'm a senior lecturer at the University of the West Indies School of Education, Mona campus in Jamaica, and I'm very pleased to be sharing the workshop with you. I will now ask the first presenter, Dr. Selvaraj, to upload his presentation while I do the introductions. So you may share your screen, Dr. Selvaraj. Dr. Selvaraj is an associate professor at MGM University, India. He graduated with his PhD in remote sensing and geoinformatics from the National Institute of Technology, Trichy, India. He currently serves as an associate professor in the university's Department of Information and Communication Technology at MGM University, and he has been there since July 2022. He is involved in several academic pursuits there, to include the implementation of a seed fund project entitled Biomass Estimation and Prediction using LiDAR and Google Earth Engine, with special reference to MGM campus. Dr. Selvaraj has notable collaboration experience with international faculty in the fields of geoinformatics and IoT, or Internet of Things. And that includes Dr. Ghassan Abdo from Damascus University, Syria. He has received several honors and awards, to include the Teaching Excellence Award, issued by the Vivekananda Institute in association with the MTC Global Bangladesh in 2023. He is also a research supervisor and a member of the editorial board of the Remote Sensing Technology Journal in Singapore. And he is a sectional editor for a book chapter in the Pandit publication in India. His presentation would be on IoT applications, and I welcome you, Dr. Selvaraj. You may proceed with your presentation. You have 20 to 25 minutes, and then we'll take question and answers for another 5 minutes. Thank you.
Thank you, ma'am. Thanks for that good introduction about me. I welcome you all for this workshop on IoT applications entitled Power of IoT and Comprehensive Guide to Application and Implementations. So as we know that already, that what do you mean by the Internet of Things? For example, if able to connect our devices to the internet, exactly what do you mean by the IoT? There is no any exact definition for that, right? Different research are doing different aspect in the research in IoT domain. But when we talk about particular IoT, from a experience point of view, and also I have a lot of experience in the IoT applications implementation in the patent and the scientific publications. So I can say that if you have any systems and if you have any devices, even let us consider the single devices. There is no any like more than one devices. Let us consider if you have any one device that to be connected with internet, that is exactly what you mean with internet. So in this slide, you can see here, there are n number of devices here, and each connected with internet. So this is what exactly what you mean with Internet of Things. So in previously, before development of the IoT, normally, in fact, IoT is belong to machine communication only. It is a subset of machine to machine. So and a lot of confusion is there, right? Which one is advantages? Like whether it is M2M is have a lot of advantages than the IoT. It's not like that. But basically, it is derived from the M2M. That means machine to machine, because normally we make a communication between two devices. For example, let us consider one device, device 1 and device 2. For example, sensor 1 and sensor 2. The sensor 1 sensor 2 be connected to communicate each other. So like that, for example, let us consider that any remote displaying devices that to be connected with sensor. So that is also to be connected with machine to machine. So I can say exactly when we talk about Internet of Things is derived from the machine to machine communication. So you got to understand basically. So this is what normally that is IoT application of this. These are the layers very important. For example, when you go for that, the first layers, perception layers, because basically we need a data sensing layer. So can we go for that perception layer in which all the sensors to be integrated? So here, when we talk about that guidance about IoT implementation, first you got to think about what are the sensors are there. Suppose, let us consider, suppose if you have any problem statement and unfortunately you don't have any sensor, so that time what you do is that you can go for the development of the sensor. So definitely it is possible, and also having the development of the carbon credit monitoring system. I have used one sensor, but unfortunately there is no sensor in order to support with IoT. So what I do is I'm going for that development of the carbon credit measurements under the soil. I'm measuring the soil carbon credit under the soil. So the thing is that we need a perception layers basically, right? So unless perception layers, we cannot go for that any business layers, and even that we cannot skip to application layers. So basically, the foundation is that sensor. There are, we know already, right, foundation of the sensor like active sensor and passive sensor. So that is very fundamental. Accordingly, you have to look on it. What kind of sensor is highly needed for that our application? And as we know that already, that the processing layer is also very important nowadays. We are using the cloud computing devices, because when we talk about the machine to machine and IoT communication, normally the machine to machine we are not using the IoT cloud, right? I mean any cloud, not only the IoT cloud, and also we can go for that cloud computing. And recently we are using green computing, fog computing, different computing technology development are there. So actually the computing devices to be connected with internet, right now that is what the big problem, because we need to post the sensor data actually, right? Once application layer, sorry, once perception layer is implemented, now what I want to do is I want to transfer the information from the perception layer to application layer. I mean, for example, when we go for that any outcome devices, I mean, what we can say that is what master and slave, right? So when we talk about the master and slave, which one device to be master and which one want to be slave, this is a fundamental of the microprocessor. And also I'm telling that, right, if you want to develop in the IoT device and IoT expert, first you have to start with microprocessor, microcontroller, then followed by digital system and how it is processing. And after that, we need to study about the cloud computing technologies. So a lot of things are there. But these IoT architectures, definitely we need 5 layers. Unless 5 layers to be completed, we cannot achieve the IoT application, basically, right? So this is what I said right earlier, that cloud computing is right now we are talking about that, because the cloud computing, I am saying that whenever you can go for IoT, normally we'll be expecting the real-time implementation, problem statement. For example, I want to know the humidity level of that, humidity level of the particular place. For example, that even we can say the temperatures, real-time implementations. So real-time data we needed. So if this is the case, we need to added features there. For example, when we go for feed this the data set collected sensors or IoT devices, so that can generate the data. For example, let me connect on IoT device and with internet. The cloud computing going to store the we can access the data. Is that we analysis of the data. So after that, I'm saying that the IoT sometimes when you go for oriented, in that what is right after application is there for analytics, cloud analytics is there, and you pre separate part they different part and it will cloud and for real time implementation this FACA meeting is very important for real time implementation. We talk about the IoT right started with like microprocessor, microcontroller. Nowadays we are using that application point of view. When we talk about point of view, better I will recommend two things is there. One need is we need is it's more because normally not recommend for that respect for that. Suppose any participant wanted to implement in real time and you need two requirements for that Arduino and like microcontroller. You need even devices. Even I'm doing when we talk about IoT system, I made one controller as per my requirements. I made some sensor per it. I can go for I went for that power so I control the power. Times when you go for the data transmissions, normally the sensor is go. My first title that IoT pattern even in mangrove right now also it is there, but sometimes even implemented in 2021, but on that right now. So that is cloud. I can this I can control this. So that is why I need a that access these and need devices. I mean physical that to be controlled IoT cloud computing because right. So parameter in that Tamil Nadu, that is what that study area. So now I want to access sir. So that time I can make computing also. So keep in mind that there are thing easier. One is for computer that microcontroller. So micro and another one is for computing. It's enough. IoT taxonomy and the taxonomy I said these are the 5 layers button pre-processing and so we need to acknowledge in different layers. For example, to go for the application point of view, like that I said analysis. For example, because IoT is going to vast in which I want is the information particularly pages. Want to go for particular information. Is therefore consider there were getting the data in real time, right? From different. Now I want to access particular pump. So that time I use of the SQL knowledge is also. So use of that I would expect you the software knowledge is also. So these are the taxonomies that classified according to that IoT domain. And when we coming to that system, so this is very important part, right? And this is very when we make use of that IoT real time the operating. So normally that in most of the case, right, in globally Linux, it's very good operating system that 78.8% of the people are using. Also, I'm that real time implementation. In real time monitoring system. Those also, but of the IoT operating system, especially if you go for Asst Prof, that Linux is also good for that. So we need a communications protocol to transfer the information to the most button is the Zigbee is a communication message coding and telemetry also we are using, and right different IoT open source cloud computing tools are there. For example, mosquito button tool, we can that and we can make use of through that cloud is the best one. This Zigbee and application, and sometimes we also because for example, if you go for small applications, and I feel that time Wi-Fi also. And right now, most of the devices in the market that are Node MCU, which is very powerful, and it's like both Bluetooth Wi-Fi also. So that Wi-Fi available, and mostly that if you go for that, the time we can make use. So we have to choose processor or going to use. So accordingly, fit this kind of communication tool so that we will not get any accuracy. We will not get any disturbance in the accuracy button. Here that Node MCU is said powerful, we are using the for real time. So as I said earlier that Node MCU controller exactly media node we don't want to do computer science node is right in there, right? So that is different, but in this node is it's similar way, but the thing is that we are developing that concepts. You do want to do what is the disadvantages there. It's like that, but the node MC is a common point. We can connect all the send connected in the particular node and extracting this information in control unit also. It is one of the reasons for that. So this is what why is popular. Even I made use pattern application, right? Used simple ESP to only the just it's like and good. Also speed also very high. When you do some implementation, very even I can get in information microseconds also. And milliseconds sometimes even assume at equal to 0, we cannot assume. And let us consider it to equal to milliseconds, only milliseconds. So by the time this, you know that node MCU is working very powerfully and is giving data and delivering the data in time. So this is why. So these are the architecture of this node MCU, we know, right? And actually, what we need to do is that we have to go through that what are the pins are available. For example, when we talk about the IoT application, when I go for the implementation, first I will think about analog and digital sensor. Okay, for example, the sensor in two types, right? We can go for that analog sensor or digital sensor. What kind of sensor you are going to use, and whether the board is having such kind of option is there. For example, let us consider Asst Prof I. I'm telling that right, we cannot convert easily that analog to digital conversion. It is not there in options. In it is option in that Raspberry Pi, but whereas we go for audio.
Dr. Selvaraj, I think we've lost you. We're not hearing you. Okay, I think we've lost Dr. Selvaraj. In the meantime, he may be coming back in. Dr. Krishnan, could you try and reach him, please?
I'll try my best, Dr. Debra. I'm driving. No issues, but I'll try him. Or otherwise, can we do one thing? We'll ask next presenter to start, and then we'll ask him to join later and complete it.
Yeah, sure. In the meantime, if you have any questions for Dr. Selvaraj, could you type it in the chat so that when he comes back in, we will have the questions there, and I can just relay those questions to him. We want to thank him in the meantime, before he comes back in, for his informative presentation. Certainly it helps to lay the foundation for the rest of the other presentations. And I'll now ask Dr. Priya if you can upload your presentation while I do your introductions, please. Okay, Dr. Priya Loganathan is a senior data engineer at Julius Baer, Singapore. She has also held the position of assistant professor at Bannari, Amman Institute of Technology. She is a graduate of Anna University, Chennai, India, and she is certified in Oracle with extensive technical experience to include ETL, Informatica, Oracle SQL, PLSOL, Teradata, MySQL, Unix Windows environment, Hadoop administration, and big data. And she also has a strong working knowledge in agile methodology. Dr. Priya also has experience in supporting banking and life science projects with strong service management, domain and transition skill sets. Among her current publications is her most cited one on the role and regulation of autophagy in cancer. Her presentation is entitled Revolutionizing Industry with Internet of Things, or IoT, Unlocking New Possibilities. You may proceed, Dr. Priya, with your presentation.
Thanks, Mrs. Debra, for your wonderful introduction.
You're welcome.
बस वो ले साग के टाइम लाइक पर डाल के बड़ा पूरा स्कूल बहुत ज्यादा कुछ इधर रोड को काम चल रहे हैं तो पहाड़ में जाए
Can you please ask the participants to mute themselves?
Yes, please. Can you mute your mics, please, while the presentations are going on?
Okay, so Dr. Selvaraj, that was very wonderful presentation, and I got to learn a lot from the presentation about IoTs and all. I was actually looking for a live demonstration, but okay, we will go for the next time. So now let me start giving you a brief introduction and an idea of what IoT and how it is playing its role across industries, unlocking the new possibilities and can you hear me? Yes, am I audible?
I'm hearing you, but you're a bit soft, Dr. Priya. If you can raise your volume some.
I can do that.
You're welcome.
So the rapid advancement of IoT has urged actually in a new era of transformation across various industries. It is actually empowering the business to unlock predictable levels of efficiency. It will also actually help us to optimize and innovate new things. So, like if you see IoT, probably the previous presentation we got to know about that it has many interconnected networks of physical devices, sensors, and softwares are interconnected. And when all these things are going in hand together, this becomes a very good game changer in revolutionizing the way we actually approach the industry processes and those asset management and customer experiences. So, one of the primary benefits of IoT in industry sector is actually to enhance the visibility and control that it provides. So, by integrating IoT sensors and devices throughout the production chain, companies can gather real-time data on equipment performance, resource consumption, operational efficiencies, etc. So this data-driven approaches actually enables predictive maintenance where potential issues can be identified and addressed before they lead to a costly downtime or equipment failures and so on. So if you see, moreover, this IoT-powered automation and optimization have actually transformed the manufacturing landscape itself. So right from the supply chain, automations, integrations of IoT with different technologies, it is all streamlined in the process of production processes. It will also reduce errors and increase output without any compromising quality. So this level of automation not only boosts the efficiency, but also it frees some human workers to focus on high value tasks, fostering a more collaborative and innovative work environment. So beyond the factory floor, IoT is also revolutionizing the way companies interact with the customers. Like if you see embedded sensors, the sensors will actually get embedded itself into any hardware. Say we have our smartwatches. What does smartwatches do is actually, it is actually a device wherein the sensors are embedded into a device and that will actually connect and gather the heart data. You can say the walking steps, all it also. So that is actually sort of, even we can say that's healthcare as well. Also, it is revolutionizing the businesses and also so on. So it can also gather valuable insights into customers' usage patterns, preferences, and paying points also. So actually, the data that can be leveraged to enhance the customer experiences. It also develops more targeted and personalized offerings. So like the daily usage can be the examples of those things. As IoT ecosystem continues to evolve, the opportunities for transformation and innovations are endless. You see. Okay, so if you see, when compared to your olden days, now the rise of internet is high. So the rise of Internet of Things is also high. So the IoT has emerged as a transformative force. It reshapes the way we interact with the world. This interconnected network of devices, sensors, and its applications has actually, you see, it's unlocked predicted opportunities. It also drives more innovation. It also progresses across a wide range of industries as well. As a part of IoT revolutionization, we gather and analyze vast amount of data. If you see, sensors are embedded in everybody's everyday objects, right from the home appliances that we use to industry machineries, etc. When you see this home appliances, we can use our mobile phones to switch on our AC, to switch on our car as well, to switch on and off our everyday utensils or any objects that we have. Also, if you take any farming applications, like we sit in a very remote place, even when we wanted to turn on the motors of any farm, we do it right from the applications or mobile phones that we have in a hand. This is a very basic home appliances. And also, when you take very big industrial machineries, it also does the same thing. So continuously collecting information about the environment, the usage pattern, and performance metrics. All these things actually helps. Okay. So this data is then transmitted over the internet, enabling real-time monitoring, remote control, and predictive analytics, etc. The impact of IoT is particularly evident in the industrial sectors, where it has revolutionized the way business it operates. So by integrating IoT-enabled system into a production process, companies can optimize the workflow, improve their asset management, and also reduce their downtime. So predictive maintenance, if you see, for example, users sensors data to identify potential equipment failure before they occur. Okay. So this is very a good example to take predictive maintenance. Before any equipment is there to fail, the sensors will be able to analyze how it will occur and when it will occur. So allowing that for any proactive maintenance and avoiding costly disruptions, etc. Beyond the factory floor, this IoT is also transferring the way we live and interact with our everyday surroundings. Smart home technologies powered by IoT allow homeowners to remotely control and monitor every day by energy consumption to any security systems. That will actually result in increased efficiency and convenience as well. And also it will help us to save the cost also. So similarly, if you see in the way of transportation, IoT connected vehicles and the infrastructures are enabling smarter traffic management and improved road safety and more personalized driving experiences. Examples, if you take any college vehicle or school vehicle, almost all of the vehicles are connected with the sensors. Even the same information, every live tracking is being transferred. It is being shared across the parents so that the parents can live without any fear of fear of the child, without any having fear of the child's safety. Okay, that's one example of vehicles. If you take healthcare industry, we have also witnessed and transformative power of IoT. Many wearable devices, mostly 95% of the of people are actually having wearable devices. Wearable devices and remote monitoring systems can track the patient's vital signs, the medication adherence, and active what you say, the active levels, which will also enable the patient's personalized care. Okay, so yeah, so as the IoT ecosystem continues to evolve, opportunities for innovation is actually very high. Okay, so this is all about how the Internet of Things is raised. So transforming traditional industries to an IoT industries. So if you see, IoT has emerged as a transformative force, reshaping traditional industries and unlocking new avenues for growth and innovation. As if you see, IoT technologies continue to evolve. There are a number of enabling a business to rethink established practices and processes, driving remarkable changes across a wide range of sectors. Okay, so one of the industry that has been profoundly impacted by the rise of IoT is manufacturing, if you say. So by integrating IoT-enabled sensors and automation systems into production workflows, manufacturers can actually gather real-time data on equipment performance, resource consumption, and the overall efficiency is also improved. So the construction industry also has embraced the transformative potential of IoT. If you see smart construction sites equipped with IoT connected sensors and devices can monitor projects progress as well. So it can also track the asset utilization and optimize the resources allocations and all. This level of visibility and control actually not only enhances project management, which is actually allowing us to improve work safety and reduces the risk of delays and cost overruns as well. If you see the energy sector, IoT is revolutionizing the way utilized and also it generates, distributes, and manage the power as well. Smart grid technology, it is also helping us to enable IoT, which will allow us to real-time monitoring of the consumption of the energies and so on. Okay, so this healthcare, if you say, as I have discussed already, most of the patients, not only the patients, most of the people are having wearable devices. Not only these wearables, devices, if you say, even the hospitals, patients are connected with most of the patients, be it in-house, be it outpatients, they are connected with wearables, can continuously monitor patients' vital signs, track medicine adherence, and also provide early warning signs of potential health issues. Okay. So the data-driven approaches enables healthcare providers to deliver more personalized practice to discuss on how traditional industries are transformed into IoT industries and IoT sort of industries. Okay. So how this is helping us to improve operational efficiency. Okay, improving our operational efficiency through IoT is a very smart idea. IoT has emerged a powerful tool of organization seeking to enhance their operational efficiency and drive continuous improvement. Okay. So by integrating IoT-enabled technologies into the workflow or business across various industries, and this is also helping us to unlock new levels of visibility, control, and optimization. Okay. What is a streamlining process? In today's fast-paced business environment, the ability to streamline business process and maintain real-time visibility into crucial for the organization will help us to see and stay ahead of the competitions and all. So the emergency of or the emergency need of IoT is emerging. The IoT to provide a powerful solution for all the challenges that we face. So transforming the challenges, the way the business people think and operate, and they also optimize their work. At the heart of if you see IoT's impact, process of streamlining is its capacity to gather and analyze vast amount of real-time data as well. So by integrating IoT-enabled sensors and devices throughout their operations, will help us to monitor the performance, efficiency, and utilization of their asset as well. So if you see logistic also, the same way it helps us. Hope everybody know what is the supply chain management. For supply chain management, manufacturing everywhere, this sort of IoT devices are transforming the whole of traditional ways. Okay, so if you see about this real-time data monitoring, real-time data collections and analysis enable most of the businesses to identify and address more of bottlenecks. It also optimizes resource allocations, and it makes informed decision based on the actual up to the minutes insights as well. We cannot really say as up to the minute, up to the seconds also it connects. Okay. So like we say, gone are the days of relying on outdated reports or paperwork or devotions. IoT powered real-time monitoring empowers organization to respond to changes conditions as quickly and effectively. Okay, so if you take one example, or one of the key benefits of IoT is streamlining the ability to implement predictive maintenance strategies. That is what is most of the IoT devices, IoT applications do. If you take examples of smartwatch that we wear, smartwatches that is connected to our hand will actually help us to track the heart beat predictions. So when we closely monitor our heartbeat for a day or two, when it is online, it is fine. If it is not correct, if it is not online, So obviously, we are actually predicting that we actually fall somewhere in. Or the sleep maintenance or sleep tracking also we do the same. So we will be able to predict what is going to happen in the future. That will actually help us to think advanced in sort of those ways. So all these things allowing us to proactively maintain and repair ourselves, machines or whatever. So this is all about how improving the operational efficiency. Okay, so enhancing customer experience with IoT. So the best example that everybody can easily know is the workplace that you are in. Most of you people would be working, would be a student of a student of any institute. Wherever you see, whatever you see, obviously now the days are actually changed to our IoT enabled places. So,
one moment, please, Dr. Priya. Could you close your mics, please, so that we would not have any distractions while the presentation is being made? Thank you. You may proceed, Dr. Priya.
okay, so the personalized interaction with IoT, if you say, IoT powered data analytics and automations will allow the organization to tailor their products, services, and communication to individual customers. If you think about the support of IoT, it can detect the issues very proactively and trigger the automated support, which will actually minimize the customers' frustrations and all. If you see about enhanced convenience with IoT, see the IoT-enabled smart homes, wearables, and mobile technology allow customers to effectively or effortlessly control and manage various aspects of their lives, from home automation to healthcare monitoring, delivering unparalleled convenience and improving their overall quality of life. So enabling a data-driven decision making. Actually, if you say the IoT generated data, when coupled with advancement analytics, with AI, with any machine learning and all, will actually help us to actionably inside that can inform strategic decision making. It also helps us to optimize the operations and drive continuous improvement across various aspects of the business. So if you see real-time monitoring, this actually I've discussed previously. It helps us to identify the emerging trends, response to any changing in the market every time, or agile manner can be used to predict the real-time monitoring. Predictive analytics, if you see IoT powered predictive analytics leverages many sensors data and machine learning algorithms. This helps to proactively address challenges, minimizing the risk, and make more informed decisions. Okay, so okay, so just a minute. Yeah. Now about the supply chains, if you see, okay, I'm audible still. Okay, so we everybody know supply chain is where is what we actually we face most of the problems. So for even for all the supply chain possibilities, if we have any IoT device connected, we will be able to collect and analyze real-time data in the supply chain process. The IoT connected sensors and tracking devices can provide detailed information on the location, condition, and status of the goods as they move through the supply chain. See, this granularity and visibility allows organization to optimize the inventory levels and improve transportation planning and reduce the risk of disruptions and delays. Disruptions and delays. Okay. So moreover, IoT driven supply chain management extend beyond internal operations by integrating IoT technologies with customer facing many applications every up to the minute updates of the orders, fostering greater transparency and trust. If you use IoT in supply chain management, transparency and trust is the most needed. What if you say thing to the people? Okay, so if you see unlocking new revenue streams with IoT, okay, so IoT enabled devices and as the cloud provides software as a service platform, both these things offer or both these things allow organizations to shift from one-time product sale to recurring revenue streams through subscription-based models. Okay. So if you see monetizing the data, the wealth of the data generated by IoT connected devices and systems can be a valuable asset for the organization. By leveraging advanced analytics and monetization strategies, most of our business can transform their data into revenue streams, such as if you see selling insights, offering data-driven services, or the license data to the third-party partners can also be provided in terms of this monetizing data. If you see IoT-enabled products, it helps us to create new revenue sources. Also, it forces stronger brand loyalty through a continuously evolving IoT-powered product ecosystem. Okay, this is about new upcoming of your the IoT devices. Then for anything and everything, we will have shortcomings. No, so this is what overcoming the IoT adoption challenges. The successful integration of IoT technologies require addressing key challenges such as data privacy and security concerns, also technological interoperability, the need for robust infrastructure, and the development of clear governance framework and the industry standards to enable seamless and secure IoT deployments. So this is about the future of IoT and its trends and predictions. Obviously, the fast evolving world, as the IoT continues to evolve, the future of this transformative technology holds immense potential. Okay, so even the researchers, experts predicts that in the coming years, we'll see the IoT ecosystem will expand exponentially with a number of connected devices worldwide to reach, it can also reach to 10 of to any extent. Okay, the convergence of IoT with any emerging technologies. If you see the 5G, AI, edge computing, blockchain, everything will lead us to a most smarter cities and the most safer cities as well. So the more efficiently the supply chains, personalized healthcare, and automations, many core industries and all will 100% gain their success based on the installation of IoTs and all. This is actually the predicted future of IoT. So that's all here for me to present to you people today. You can feel free to post your queries if you have it. And thank you.
Thank you, Dr. Priya, for enlightening us on all the possibilities that we have in the Internet of Things and the applications. Do we have any questions for Dr. Priya? You may type it in the chat, or you may open your mic since we are not a large group. Okay, Dr. Priya, you gave us the perspective mostly from industry. There are a few of us who are in education, higher education. Could you give us some examples of how we can, the possibilities for improving efficiency and operations using the IoT for higher education and even for researchers and students?
Can you hear me?
Yes, we can.
You wanted to give me example how it is useful for higher education, right?
Yes, please.
Yeah, as I own a laboratory called as a blockchain laboratory, wherein I have many IoT devices connected to me. For example, if you see, actually to collect and analyze data for any research equipment, okay, rather than collecting it manually, the data collection and storage can be done using any smart IoT devices in the field of studies, which will enable us more effective data-driven research for the experimentation that we do. Okay. So when we do this, it will actually help us to foster a culture of innovation and entrepreneurship in the campus and SKIT growth. Okay. So if you wanted to improve any campus operations and all, utilizing IoT connected systems will help us for better management of campus facilities like, for example, if you wanted to use an optimization parking, if you wanted to manage any cafeteria operations or automate building maintenance and all, can be done easily. And these sort of problem statements can be picked up and given to students for their projects as well. So in-house projects will help us for the students to gain more knowledge with the help of when they implement their project work with the help of any IoT devices.
Thank you. Yeah, thank you very much for that illustrative example. Certainly, as a researcher, that would certainly be of benefit to me and even the graduate students I supervise. So thank you very much. All right, I'm not seeing any more questions. I am seeing in the chat, excellent presentation indeed. And so thank you very much, Dr. Priya. Our next presenter would be Dr. Pankaj Dadheech. And I'm going to ask him to upload his presentation while I do his introductions. Dr. Pankaj, you can begin uploading.
Yes, ma'am. Yes, is it properly visible?
Yes, it is. Dr. Pankaj is a professor of computer science and engineering at SKIT, Jaipur, India. He has a wealth of knowledge and experience in a wide range of technical domains, including C++, JavaScript, HTML, and others. He is committed to advancing knowledge in the field of computer science and engineering, or CSE, and his contributions to SKIT has not only transformed the curriculum, but also inspires students and colleagues to explore new technological frontiers and innovative solutions in CSE. I am pleased to present Dr. Pankaj. You may do your presentation.
Yes, thank you for giving me this opportunity. Today I am presenting the data analytics for IoT. So you can see my outline of this presentation is introduction to big data analytics, then overview of Hadoop ecosystem, MapReduce architecture, and MapReduce job execution flow, MapReduce schedulers. So first, big data analytics. So collection of data whose volume, velocity, or variety is too large and difficult to store, manage, process, and analyze the data using traditional databases. So big data analytics involves the data cleansing, data munging, data wrangling, data processing, data visualization. So you can see the key characteristics of big data, like the data volume, where you can increase the data. Um, the data is increasing day by day, so you can see the large amount of data is generating day by day, and in the seconds, the voluminous amount of data is generating. Then processing complexity, so changing data structure or use cases, warranting additional transformation techniques. So then data structure needed, where greater variety of data structures to mine and analyze the data. So these are the key characteristics of big data, where you can see the data can be structured, semi-structured, quasi-structured, or unstructured. So the structured data, like data containing a defined data type, format, or structure, for example, transaction data and OLAP data, or the semi-structured data where textual data files with a discernible pattern enabling parsing. For example, XML data files that are self-describing and defined by an XML schema. Then quasi-structured, where textual data with arithmetic data formats can be formatted with effort, tools, and time. For example, web click stream data that may contain some inconsistencies in data values and formats. Then unstructured data, so the data like text, image, video, audio, PDF, everything data is unstructured data, where the data that has no inherent structure and it is usually stored as different types of files. So there are structured data like it is stored in tables, semi-structured data like stored like in XML files, or the quasi-structured data where the data can be typed like this, and unstructured data where all the data like text, video, audio, PDF, all the data comes under unstructured data. So the big data analytics use to process the data, or there are the three V's of big data. So in the three V's, like first is variety. Variety means it includes the different types of data, like structured data, unstructured data, semi-structured data, all of the above, like text, audio, video. The velocity. Velocity means it refers to the speed at which data is processed, like batch, real-time streams, and like this. And the volume. Volume refers to the amount of data. Means voluminous data. It is maybe it may be terabytes in data, petabyte, zettabyte, or exabytes, or the record transaction files tables are maintained in this. So data is generating day by day, and you can see how the data is increasing day by day. So another V is like five V's of big data. So first three V's we already discussed: volume, velocity, variety. Volume means data is at rest, and that data maybe in the amount of large amount, means like exabyte, terabyte, petabyte, zettabyte. And the velocity, where the data is in motion, like streaming data requiring milliseconds to seconds to respond. Variety of data means data in many forms, like structured, unstructured, text, multimedia, everything data is in various different formats. It is variety of data. Then veracity. Veracity is another way of big data. So you can see the data in doubt, where uncertainty due to data inconsistency and incompleteness. So ambiguities or latency deception model approximations are there. And value means data, how data is useful to create an asset or money. So data into money. So business models can be associated to the data. Then Hadoop, HDFS, Hadoop Distributed File System. So it is responsible for storing the data on the cluster, where data files are split into blocks and distributed across multiple nodes in the cluster, and each block is replicated multiple times. So default is to replicate each block 3 times, and replicas are stored on different nodes. So this ensures both reliability and availability. So Hadoop distributed file system, where you can see the name node is there, which stores the metadata, and the metadata like user dynafu 124. So you can see the blocks like this. One is stored at 1, 2, and 4. Like this, 3 and 5 are stored uh, are stored at 3 and 4 and 5. So you can see the data nodes store the blocks from files, and where name node, where you can see the block 3 is available at the node 3, node 4, and node 6. So you can see, so block 3 is available at node 3. These are nodes, node 1, 2, 3, 4, 5, 6. There are total 6 nodes. So the block 3 is available at node 3 and 3, and at node 4 and 4, 3 is there, and the block 3 is at N6, which is here. So you can see block 3 is stored at N3, node 3, node 4, and node 6. Another block 5, for example, block 5 is stored at node 2, node 3, and node 4. So block 5 is available at node 2. This is data node 3, and this is data node 4. So block 5 is stored at data nodes 2, 3, and 4. Then Hadoop daemons. So Hadoop is comprised of 5 separate daemons. So the name node, which holds the metadata for Hadoop distributed file system, and secondary name node, which performs housekeeping functions for the name node, is not a backup or not a standby for the name node. The data node, which actually stores actual Hadoop distributed file system data blocks, and the job tracker, which manages map reduce jobs and distributes individual tasks. Then task tracker, which is responsible for instantiating and monitoring individual map and reduce tasks. Then Hadoop distributed file system architecture, where you can see the metadata operations are here, and the name node where metadata name replicas are stored here, the block operations on various data nodes. The data nodes are separated with racks. So rack 1, rack 2, like the various racks will be there, and the client which writes on these data nodes or in the blocks, and the application is there, the client is read, and this is the Hadoop distributed file system architecture. So what is Hadoop MapReduce? You can see MapReduce is the system used to process data in the Hadoop system. So it consists of two phases, map and then reduce. So each map task operates on a discrete portion, one Hadoop distributed file system block of the overall data set, and the map reduce system distributes the intermediate data to nodes which perform the reduce phase. So the Hadoop map reduce, where map input key input value is there for each word WN input value, emit W1, so input to the mapper. So 3414, the cat set on the mat, like this, another key value pair. So key and value like the R word set on the sofa. So this is the input to the mapper, and output from the mapper will be, so this sentence, the cat sat on the mat. So every word associate with the value, key value. So then one, cat one, sat one, on one, the one, mat one. Another sentence, the R word sat on the sofa. So the R word sat on the sofa. So we give value 1 to each word. Then you can see the mapper input is this. The mapper input was this. The cat sat on the mat and the arbor sat on the sofa. The mapper output, where you can see the cat sat on the mat, the arbor sat on the sofa. So we give value 1 to each one. So another phase where you can see add up all the values associated with each intermediate key. So in reducer phase, so reduce the output key intermediate values. So first set count equal to 0 for each v in intermediate values, count equal to count plus v, and emit output key and count. So you can see R word is one word, cat is one, mat is one, on is two. So on comes two times. You can see in first sentence it is on, and in second sentence it is on. So on comes two times, so it is reduced to 2. Then sat comes 2 times. You can see the sat is also 2 times in both sentences, sat and sat here. Then sofa 1 and the comes 4 times. So you can see, so the comes 2 times in first sentence and 2 times in second sentence. So it is 4 times. So it is reduced output is Harvard 1, Cat 1, Mat 1, on 2, Sat 2, SOFA 1, and the 4. So this is the reducer input and the reducer output, where you can see the comes 4 times 1 1 1 1. So it is add up the 4. SOFA 1, Sat 2, like this. So how do map reduce where mapper input is given like this? The cat sat on the mat, the Albert sat on the sofa. In first mapping phase, every word is associated with one key value pair. Then shuffling is there. So hardware, cat, mat, on, sat, sofa. The how many come times they are occurring. So we are represented here. Then reducing phase where we count all these values. There comes 4 times, so it is 4. Set times 2 times, on comes 2 times. So the final result will be Harvard 1, Cat 1, Mat 1, on 2, Sat 2, Sofa 1, and the 4. So this is how Hadoop MapReduce is working. So the preloaded local input data is there, then mapping process where the intermediate data from the mappers and then value exchange by shuffle process, then reduce process generates the outputs, and the finally output stored locally. So the lots of data is being collected and warehoused like web data, e-commerce data, purchase at department, grocery store, bank, credit card transaction, social network. So you can see in industry like healthcare, it reduces the cost of care. In public services, it is used for preventing pandemics. In life sciences, the genomic mapping is there. In IT infrastructure, where unstructured data analysis is there. Online services with the social media for professionals like government, medical, internet, phone, TV, financial, retail is there. Then big data analytics where healthcare, the situation is like this: poor police response or problems with medical care and triggered by shooting of just students. So the event law local doctor to map crime data and examine local healthcare. So these how the situations are handling with these in healthcare sector. So use of big data. So you can see the crime map from medical billing reports of 3 hospitals. So it can concise and how it can be tracked. So we use the big data. Then key outcomes where city hospitals and it provides expensive care, low quality care, reduced hospital cost, realizing 80% of city medical cost. It now offers preventive care over the phone or through home visits. So how this big data analytics used in healthcare, in public services, where you can see the situation like threat of global pandemics has increased exponentially, and the pandemics spreads at faster rates, more resistance to antibiotics. So for using big data, we created a network of viral listening posts. Then it combines the data from viral discovery in the field and research in disease, hotspots and social media trends. Then using big data to make accurate predictions on spread of new pandemics. Then key outcomes were identified a fifth form of human malaria, including its origin. It identified why efforts failed to control swine flu, proposing more proactive approaches to preventing outbreaks. Then situation where broad institute like MIT, Harvard mapping the human genome, or you can see in 13 years map 3 billion genetic base pairs, 8 petabytes, or it developed 30 plus software packages now shared publicly along with the genomic data. Or the key outcome like using genomic mappings to identify cellular mutations or causing cancer, other serious diseases, or innovating how genomic research informs new pharmaceutical drugs. So in IT infrastructure, you can see explosion of unstructured data require new technology to analyze quickly and efficiently. So by using the big data, the duck cutting created Hadoop to divide large processing tasks into smaller tasks across many computers, and it analyzes social media data generated by hundreds of thousands of users. Then key outcomes where you can see the applications range from the social media sentiment analysis, war time charter, natural language processing, or another is you can see online services where the opportunity to create social media space for professionals. So by using big data, it collects and analyze data over 100 million users and adding 1 million new users per week. So how this data is handling by big data, and the key outcomes were LinkedIn skills in maps, job recommendations, recruiting, establishing a large or diverse data scientist group as founder and believes this is the start of big data revolution. So then Hadoop ecosystem. So Apache Hadoop is an open source framework for distributed batch processing of big data. So it includes the Hadoop MapReduce, Hadoop distributed file system, HBase, Yarn, Zookeeper, Pig, Hive, Mahout, Chukwa, Cassandra, Oro, Uzi, Flume, and Scoop. So a Hadoop cluster comprises of master node, backup node, and number of slave nodes. So the master node runs the name node and job tracker process. The slave nodes run the data node and task tracker components of Hadoop. The backup node runs the secondary name node process. So you can see mainly the role of name node is to keep the directory tree of all the files of the file system and track where across the cluster the file data is kept, and it does not store the data of these files itself. So client applications talk to the name node whenever they wish to locate a file or when they want to add, copy, move, or delete a file. Then secondary name node, where a single point of failure of the HDFS cluster. So an optional secondary name node, which is hosted on a separate machine, creates checkpoints of the namespace. Then job tracker, it is the service within Hadoop that distributes MapReduce tasks to specify nodes in the cluster, and ideally the nodes that have the data or at least the same link. Then task tracker, it is a node in the Hadoop cluster that accepts MapReduce and suffer tasks from the job tracker. So each task tracker has a defined number of slots which indicate the number of tasks that it can accept. Then data node, so a data node stores the data in Hadoop distributed file system. So a functional Hadoop distributed file system has more than one data node and with data replicated across them. So MapReduce operations assigned to task tracker instances near a data node talk directly to the data node to access the files, and the task tracker instances can be deployed on the same servers that host data node instances so that MapReduce operations are performed and close to the data. So MapReduce job consists of two phases, map and reduce, already we discussed. So how the map phase, where the data is read and issued in file system and partitioned among the set of computing nodes in the cluster. Then it sent to the key value pairs, a set of key value pairs. Then map task process the input record independently, and the intermediate results are stored on the local disk of the node running the map task. Then when all the map tasks are completed, the reduce phase begins, in which the intermediate data with the same key is aggregated. Then combined task, it is an optional because an optional combined task can be used to perform data aggregation on the intermediate data of the same key for the output of the mapper before transferring the output to the reduced task. So this is the how MapReduce job execution workflow, where you can see the MapReduce job execution starts when the client application submit jobs to the job tracker. So client node MapReduce program job client is there, job tracker node where it is tracking with the task tracker nodes and the map of reduced task, and the Hadoop distributed file system is used to store all the data. So the job tracker takes submit the work to the task tracker node, and when they pull the task, and the task tracker founds a separate JVM process for each task so that any task failure does not bring down the task tracker. So the task tracker monitor these spawn processes while capturing the output and exit codes. So when the process finishes successfully or not, the task tracker notifies the job tracker, and when the job is completed, the job tracker updates its status. So MapReduce 2.0 Yarn, you can see it is the original processing engine of Hadoop, where it has been separated from the resource management. So this makes Yarn effectively an operating system for Hadoop that supports different processing engine on a Hadoop cluster. So Yarn architecture divides architecture like two major functions: job tracker, which is where resource management is there, and job life cycle management, where it is into two separate components like resource manager and application manager. So resource manager is the global assignment of compute resources to applications, and it consists of two services, scheduler and application manager. So scheduler is pluggable service that manages and enforces the resource scheduling policy in the cluster. Then application manager, it is manages the running application masters in the cluster. So it is responsible for starting application masters and monitoring and restarting them on different nodes in case of failures. Then application master, where it manages the application lifecycle. So it is responsible for negotiating resources from the resource manager and working with the NMs and to execute the monitor the task. So NM, it is node manager, where per machine node manager the user processes of that machine, and the containers, which is bundle of resources allocated by the resource manager, and like memory, CPU, network, etc. So a container is a conceptual entity that grants an application the privileges to use a certain amount of resources on a given machine to run a component task. The Hadoop scheduler, it is a pluggable component that make it open to support different scheduling algorithm like the first in, first out, or fair scheduler. So two advanced scheduler are available like fair scheduler, which is developed by Facebook, and the capacity scheduler, which is developed at Yahoo. So the pluggable scheduler framework provides the flexibility to support a variety of workload with varying priority and performance constraints, and efficient job scheduling makes Hadoop a multitasking system that can process multiple data sets for multiple jobs for multiple users simultaneously. So first in, first out scheduler, where it is a default scheduler in Hadoop and maintains a work queue in which the jobs are queued. So every job which is come first can be served in first manner. So the scheduler pulls jobs in, first out manner, and the oldest job first for scheduling, and there is no concept of priority or size of the job in FIFO scheduler. The fair scheduler, which allocates resources evenly multiple jobs and also provides capacity guarantee. So the fair scheduler assigns resources to jobs such that each job gets an equal share of the available resources on average over time. So task slots that are free are assigned to the new job so that each job gets roughly the same amount of CPU time. So job pools, where the fair scheduler maintains a set of pools into which the jobs are placed, and each pool receives at least the minimum share. And when the pool does not require the guarantee share, the excess capacity is split between other jobs. The fairness, where the scheduler computes periodically the difference between the computing time received by each job and the time it should have received, is ideal scheduling. Then the job which is the highest deficit of the compute time received is scheduled last. The capacity scheduler has similarly functionality as the fair scheduler, but adopts a different scheduling philosophy. So queues, where in capacity scheduler you define a number of names queues, each with a configurable number of map and reduce slots. So each queue is also assigned a guarantee capacity. So the capacity scheduler gives each queue its capacity where it contains jobs and the shares any unused capacity between the queues. So within each queue, FIFO scheduling with priority is used. The fairness, for fairness, it is possible to place a limit on the percentage of running tasks per user so that users share a clustering. So a wait time for each queue can be configured, and when the queue is not scheduled for more than time, it can preempt tasks of other queues to get its fair share. So this is how the data analytics for IoT can be used. Uh, IoT analytics refers to collect, process, and analyze data that are generated by IoT devices. So as more devices are connected in the internet, it generates a large amount of data and that provide a valuable insight and provide valuable information from the particular data. So this is all from my side. Thank you.
Thank you, Dr. Pankaj. That was a highly technical presentation, but very instructive. I am now opening the floor for any questions for Dr. Pankaj. You may type it in the chat or open your mic, as we are a small group. Dr. Pankaj, in terms of the analytics that come out of this process, how confident can we be with the analysis, for making decisions? For example, I'm in education. For the leaders in education, those who head departments like the registrar's office, the medical faculty and so on, how confident could we be, with the results and for making decisions? So is there a level of error?
So you can see IoT in healthcare generates a wealth of data that can be utilized to gain valuable insights. So through data analytics, healthcare providers can identify trends, the predict outbreaks or track population health and personalize treatment plans based on individual patient needs. So in education, in health informatics or in integrating data analytics with health informatics has reshaped healthcare delivery and decision making. So you can see like in indoor healthcare environments such as hospitals, IoT devices can be used to monitor patients and manage medical equipment and track inventory. IoT sensors can also monitor environmental factors such as temperature, humidity, and air quality, which can help or prevent the spread of infections. So the decision can be taken uh, in another we can see in education, so the real time data processing should be there. So you can see where IoT devices in education enable educators to collect accurate data about how their students interact with the devices and applications provided to them. So analyzing this data can help you to understand more about a student's learning needs, its progress and interest. So
Okay. Yes, I can see that the process is very useful and beneficial to making the system more efficient, in that you don't have to wait a long time to get the data to make the decision. So indeed, it is beneficial. Any other questions for Dr. Pankaj? Okay, so we'd like to thank you very much, Dr. Pankaj, for that insightful and useful presentation.
thank you.
Our
Thank you, Professor
fourth,
Debra.
yes, you're welcome. You're welcome. Our fourth and final speaker would be Dr. Mekala, and I'm going to ask Dr. Mekala to upload while I do the introductions. Are you there, Dr. Mekala? Yes, okay. So Dr. Mekala Ramasamy is an assistant professor at Bannari Amman Institute of Technology. She holds a master's and bachelor's degrees in computer science and engineering and has over 10 years of academic experience in her field, to include teaching at K.S. Rangasamy College of Technology. She has co-authored several presentations in international peer-reviewed journals, to include her most recent on development of optimized cascaded LSTM, which is indexed in Scopus. Dr. Ramasamy is also a reviewer for several reputable journals, including the Indian Journal of Science and Technology. She is awaiting feedback on 4 grant applications, one of which is Smart Safety, developing a sensor-based system to prevent accidents for mobile phone users on the move. She also holds many technical certifications to include systems and usable security, building real-time video AI applications, and deep learning fundamentals. Her presentation is entitled Future is Connected, Leveraging IoT Technology for Success. It's my pleasure to hand you over to Dr. Mekala. You may proceed with your presentation.
Thank you, ma'am. Thank you for your introduction. Am I audible, ma'am?
Yes, you are. Clear. Very clear.
Can I proceed, ma'am?
You may.
Yeah, thank you, ma'am. Today my topic is the future is connected, leveraging IoT technology for success. I'm going to present the applications of IoT, particularly in the domain of healthcare as well as agriculture. Before moving on that, I want to explain what is IoT and what are the processes that are involved in it. IoT, you know that it is an emerging technology. IoT is nothing but it is an amalgamation of various communication devices that can sense and communicate with each other. Here, communication devices in the sense they are cellular devices, nodes or systems, sensors and softwares. They are connected with each other as well as they are sharing the data. From that data, we can make some meaningful analytics through which we can make some informed decisions that can help us to optimize the resources as well as time and other assets. I know that IoT is so mainly used in the smart homes. It is used to control the home appliances and assets. So it is not only used for smart homes. It mainly used in all kind of domains. So IoT in the sense nothing but here machines they can interact with each other. You know that IoT it can consist of various sensors. Sensors can produce various data. The sensed data that can be shared among the devices, which may be of any type of application, healthcare application, or any other kind of industry application. That is IoT controlled manufacturing also. First, I want to emphasize the role of data in IoT. Here, so initially the data is collected from various resources such as sensors, embedded devices, and electronic gadgets and wearable devices. So these collected data, they are stored in the cloud platform. So either they may be stored in the cloud platform or they are shared with the mobile application devices. Here, the communication takes place between the various connected devices. So the data is securely transmitted over the devices. We want to ensure the privacy of the user's data, so that we are using some technologies like edge computing, software-defined networks, and blockchain technology. So through which we can ensure that the user's data are we are maintaining the user's data as confidential, their privacy also protected. And one more thing, the data is used along with the various technologies like big data, AI, that is artificial intelligence, which consists of major technologies, deep learning and machine learning. Here we are using supervised algorithms and unsupervised algorithms. These are mainly used to analyze the data that are received from the IoT devices, through which we are analyzing the data that is received throughout the communication, through which we can make some well-informed decisions. The decision can be made by the healthcare providers, or either that if it is if we are using in agriculture domain means the farmers can make some meaningful decisions with the help of IoT data. So next, we are moving on to the impact of IoT on our lives and businesses. How the IoT that can made impact on the various domains. So manufacturing. So here we are using IoT to control the devices that either in the production process, and also it is used for the predictive analytics, through which we can identify the downtime of the equipment, or we can control the process. The next domain we are majorly using IoT is healthcare. The major use cases of healthcare are remote patient monitoring and as well as we are using wearable devices through which we are monitoring the patient healthcare data, such as some vital data are monitored, blood pressure, heartbeat, and temperature. So through which we can identify the patient's health. If they any risk identified, they can immediately get alert or messages with the help of data analytics that is incorporated in the wearable devices. The next domain is agriculture. So in this domain, we are using IoT to reduce the resources and to reduce the wastage of resources. That so in which we can optimize the resource usages. How this happen means we are continuously monitoring the crop fields. The data that can be obtained from the sensors, such as weather patterns, crop health, temperature, humidity. So with the help of this, we can made some decisions that can prevent the wastage of resources. For example, if we are applying IoT in water irrigation means some threshold value we have to maintain. If the so it can analyze the data. If it reaches the maximum threshold means we can alert the user to turn off the device. It may be motor or it allows us to perform the water irrigation application. Some automatic application that helps us to reduce the use of resources. Then next application is transportation. So mainly we can use this in smart cities. So vehicles are embedded with IoT sensors through which we can get the data like traffic conditions, vehicle performance, and passenger behavior. If any route that contains congestion means we can change the travel pattern. We can change the route to the users so that we can avoid the traffic. And smart cities, there are so many services that are utilizing IoT through which we can make the people life smart. So mainly it is used in energy efficiency and reduced pollution and enhanced urban living and personalized health and fitness. As you know that IoT devices which allows us to track the user's data. So mainly we are using various wearable devices such as smart watches through which we can watch the user's physical activity, whether the user is lying or walking or running. And also we can analyze the user's sleeping patterns, whether they have deep sleep or so such kind of patterns also analyzed. So with the help of the data, we can provide some personalized healthcare advice or even we can advise them some medication. Then home automation. Here everything is controlled. The home appliances as well as electronic gadgets, fan, switches. So all are connected with IoT technology through which we can control them with the help of our mobile phone also. If either we are in travel or we are working in our office, we can control the environment in our home. So next one is we are going to explore the healthcare IoT. So how it is impacting the human lives. The first one, enhanced patient care. So in which healthcare IoT, which allows us to track the user's data such as heart rate, blood pressure, glucose levels. We can able to watch their movement also. If any risk or critical conditions, it will alert us. So there is no need of physical monitoring, so that it will reduce the cost as well as the effort required to monitor the patient. And sometimes we may have elders in our home. We can able to watch them from anywhere. Then early detection. So in which IoT, with the help of IoT data, we can diagnose the diseases or symptoms in early, so that we can prevent some so complex situation. Then improved access to healthcare. So another applications we can tell about healthcare means telemedicine and remote monitoring. So this is the diagram of which explains you what are all the important features in healthcare IoT. You know that IoT which provides some meaningful data. So assume so various IoT devices and platforms, they are producing data, they are overwhelming. We want to store it in efficient way, so that we are using cloud platforms, that is centralized server that can store the patient's data, such as electronic EHR data, that is electronic healthcare data, scanned reports, and patient's medical history. So all these things are stored in the centralized system. The users are given RFID enabled access. With the help of their authentication, they can able to access the data. Assume any diabetic patient who is wearing the smart device. With the help of that smart device, some meaningful data like body temperature, glucose level, and pressure level. So all these data are collected and they are stored in the database, centralized database. So all these kind of data are stored in the centralized server. So the R&D team, they can research and they can do some meaningful analysis through which they can suggest some improvised treatments as well as medicines also. So all these data are accessible by the physicians and the nurses, through which they can track the user's health as well as the status of the patient health data. The next one. So with the help of this data, we can make some well-informed decision, through which we can suggest them some based on the user conditions. We can suggest some personalized medicine, and the collection of data allows the R&D team to provide new through which they can develop some meaningful research, and they can provide some meaningful results. In order to provide so all this kind of facility, we are in need of some enhanced communication network. We want to connect every device in the IoT platform. We are in need of some efficient communication technology. For that, we are using 5G technology, which provides higher bandwidth and lower latency. through which we can get the real-time data. The term IoMT refers Internet of Medical Things. The devices that are connected in this communication is known as IoMT. Since the medical devices, they are providing data that are related to user data. That is, this medical devices facilitates efficient data exchange and interoperability. And so next topic is remote treatment and patient monitoring. The users are allowed to stay in the home itself, through which they can use virtual consultations with the help of video calls. There is no need to meet the person in physical mode. So this kind of facilities that are provided with the help of IoT facility only. That telehealth platforms, so through which the user is allowed to get the suggestions like prescriptions, refills and follow-ups, and the mental health support with the help of these telehealth platforms. Then home healthcare. If a person who is affected by some critical disease like chronic disease, they are continuously monitored. Their health conditions are continuously monitored. If any risk found, they are immediately alerted with the respective doctors or physicians. For the call is immediately sent to the relatives as well as physicians. And therapy sessions, and they are also tracked with the help of this IoT technology. Then emergency response. All these collected data that are disseminated to the respective persons, either the experts who are doctors or the concerned persons who are continuously monitoring the data, they are alerted. That is in the form of alert systems. If any changes or a disorder in the user's behavior, they can immediately alerted. That is heart rate. If any changes in the heart rate, or if the patient who is falling in the floor, this kind of symptoms, if it happens, the corresponding user get alerted, either message or a phone call received with the help of IoT devices. Then remote diagnostics. Healthcare professionals, they are who are connected over the network, and they can use this service to provide they can provide treatment based on the user's history or data. Then wearable devices. There are multiple wearable devices that are used to track the user data. Mainly they are checking the user's health metrics, such as sleeping patterns, their physical activity. Everything is continuously monitored. Then medical wearables. So since the IoT system, which is connected with the devices, since we are dealing with healthcare technology, it is connected with various medical devices such as ECG monitors, glucose monitors. They are connected with IoT system. They continuously monitor the user and provide the continuous data. A remote monitoring system. It continuously monitors the user's vital signs. That is, and the immediate data is real-time data is sent to the respective users, either physicians or respective authorized person. Environmental sensors. So even the patient surrounding area is monitored with the help of IoT system. That is in the form of air quality, temperature is continuously monitored. So this is a healthcare IoT where we are connecting multiple devices with the help of IoT technology. IoT cloud, which can store all kind of data. Since so all physicians and expert members, that is doctors, who can access the data from the IoT cloud, such as users, that is patients' health reports and records. And so initially the patient who is having some wearable devices, the device can contain some sensors. The data is sensed from the user's body, such as heart rate. So all these data are transferred over the network. Then blood pressure also monitored. This kind of data is sent to the IoT cloud. If we are wearing, for example, in this case, we are assuming the patient is wearing wearable watch. The data is stored. This real time, if any fluctuation in the heart rate or any abnormal conditions happened, the real time alert is sent to the IoT cloud. Then it will alert the doctor with the help of
I think we have a break there. What's happening? We're not hearing you.
Can you hear him?
Okay. Yes, we're hearing you now.
Okay. So this kind of data helps us to diagnose the disease early. With the help of this continuous monitoring of real-time data allows the doctor to predict the type of disease or symptoms. We can diagnose the user condition easily. With the help of this data, we can make some analytical processing, either through big data analytics or AML algorithm. We can give some meaningful suggestions. That kind of analytics also can be visualized in the form of graphs and charts. So next, I am moving on to the next domain, IoT in smart agriculture. How the IoT is helping the farmers. We can see here IoT. Here the various applications that are allows the farmers to efficiently use the IoT technology. The first one is water saving irrigation, and then crop health environment monitoring. Water saving irrigation means it can sense the water level or soil status, that is soil status, through which the user can, the farmer can identify whether the plant is need the water or not. Water saving irrigation means we can save the water with the help of IoT devices. The sensor can sense the water levels. If it reaches some threshold, means automatically it will inform the farmer to turn on, either to turn off the motor, through which we can save the water. Crop health, crop growth environment monitoring. The plant's health is continuously monitored from the start from the day 1 to day 1 to the harvest stage. Then intelligent agricultural machinery. The various equipments that are used in the farming, those equipments are controlled with IoT. Their actions and status are controlled with the help of IoT technology. Animal and plant life information monitoring. Various so livestock animals are controlled in the IoT environment. Then agricultural product quality, safety and traceability. Mainly we are using this application in the food safety, supply chain and logistics also used here. Then animal life information monitoring and plant life information monitoring, these are separate applications. This is the architecture of agriculture IoT, where different layers are available. Here, object layer that consists of crops. The user can the crops in the sense any kind of plant, the farmer who can monitor. Then livestock, it means the animals, birds. Then agricultural machinery, that the equipments for farming equipments that are used for the agriculture. Then perceptive layer, here we are using various sensors that can send data. Then global navigation satellite system, through which we can monitor the spatial data. If your farm is a very larger one, we cannot monitor at a single glance, so that the spatial data is monitored with the help of satellite images. That is remote sensing. Then GIS, Global Information System, Geographic Information System, that is also monitored. Then transport layer that consists of some various communication technologies that is based on the distance level. Bluetooth, in the sense you can communicate within a short range. Then ZigBee is another kind of communication technology. Then radio frequency technology also used. If you want to communicate with a larger distance, means we can use local area networks with the help of Ethernet, wireless LAN. The other type of network technologies also help. These are the recent technology that provides some advanced communication applications and which allows us to transmit the data at a high level. These are some application levels where we are storing our data in the cloud platform, which consists of some cloud technical terms: cloud application, cloud computing, cloud storage, and cloud service, where we are processing our data. Then user layer, here the users are available: agricultural producer, that is farmer, system manager, and end consumer. So in which so various tasks has been are performed: planting, gardening, and breeding. So animal monitoring systems, that is livestock monitoring. So in which we are mainly monitoring the vital signs of animals, is either animals' temperature, heart rate. These are continuously tracked with the help of sensors, through which we can analyze the animals' temperature and heart rate. So mainly it allows us to monitor the data. So the surveillance, that is devices like surveillance camera, which allows us to monitor the animals, as well as the sensors also continuously sending the data, like temperature data and heart rate data. Through with the help of this data, we can identify the health of the animal. If any changes in the data rate, we can separate that animal. We can provide some healthcare related treatments. This is the typical representation of a healthcare monitoring system, where animals are continuously tracked. So the feeding of a feeding system, and then temperature sensor is placed here. The IoT node, which broadcasts the data from the current location. The gateway is connecting the multiple IoT nodes. The camera, which is used to monitor the animals and birds. If any unwanted chemical components or gases available in the particular environment, we can sense that too. That is alerted to the user. Here everything is connected over the cloud storage that is connected with the main server, where the user is sent to the server is sending the continuous messages to the end user, that is remote user, is the farm owner. They can gain the information with the help of computer or cell phone. Then animal monitoring system. This is some kind of technology we are using. Sports collars. We can wear the animal is monitored with the help of sports collars and GPS sensors. The animals' activities are continuously monitored. Their animals' foraging activity, at what position they are currently available, we can able to watch it. Either currently they are walking or resting. So all these behaviors are continuously monitored. This is one kind of research that is done in the year 2015. Then Zigbee-based healthy monitoring. This is for analyzing the health of animal by analyzing the data, showing body temperature and heart rate is analyzed here. Then humidity data also analyzed. Then electronic tags for sheep. Then RFID kind of tags are given to the animals through which we can continuously monitor the sheep activity. If any animal who got lost means we can track them with the help of the tag itself. Infrared technology for pigs. We can continuously monitor the body temperature of the animal so that we can isolate that animal. If any disease identified means we can separate them and we can treat them, through which we can avoid the disease spread. That is, we can initially identify the disease that can be found to any animal mix. We can avoid the spread of that disease to other herd or animals. Wildlife rescue monitoring. We can monitor the wild animals also. If any animals missing or lost means we can continuously monitor them with the help of RFID and Zigbee protocol, as well as the IoT sensors. Plant life monitoring. So mainly we can ensure that the plant is getting the proper water or temperature, sunlight, and other things also with the help of sensors. So that is we can continuously collecting the images, plant life images. This can be done with the help of remote sensing. So what kind of information we have received means chlorophyll content, crop nitrogen, photosynthetic rate, and so on. This is the typical structure of plant life monitoring system. So the spatial data is continuously tracked with the help of satellite images. The entire farm is connected with the IoT device. So the status is continuously monitored. Nutrition sensor, moisture sensor, the humidity level is continuously monitored. If irrigation needed, we can immediately turn on the device to irrigate the plants, through which by knowing the status of the moisture, we can avoid over watering or under watering the plants. Machinery control for in the agriculture field, we are using different kind of equipments for the different actions like cultivation, sowing, transplanting, fertilization, drug spraying, feeding, irrigation, picking, and harvesting. So all these kind of devices are connected with IoT, so they can be controlled by the person. They can be controlled by the authenticated user. See here all the
I think you need to wrap up. I think you're almost there to the end.
okay, ma'am. I'm coming to the conclusion.
Okay,
So
sure.
with the help of the IoT technology, we can simplify the actions that can be done in so various domains, agriculture, healthcare, and as well as we can improvise the things what already been done in the conventional systems, so that our life standard will be improvised, and also we can improve with the help of IoT. We can do some various we can do all these kind of process with the help of automation, since the IoT helps us to automate the actions, so that we can reduce the manpower resources as well as the cost that are required for. We can enable more sustainable process. I want to thank you, the organizer. Thank you all.
You're very welcome. And that was a very informative presentation. Certainly, we agree with you that the future is connected and there are a lot of benefits to be gained from using IoT and the connectivity to the devices to monitor performance, in various sectors, the environment, in health, and so on. I would now open the floor for questions on the last topic, which dealt with leveraging IoT for success. You may type in the chat or you may open your mic, since there are just a few of us on the platform. Is there a question, Yusuf? Okay, I have one question. Whilst I recognize the benefits to be gained from, the connectivity and the monitoring with the devices, I'm concerned about any health effects in terms of radiation with these, devices attached to animals or even humans. The wearable technology. Could you advise us, whether or not there are any health risks in terms of radiation from the devices?
I hope the devices are already tested against the survival level. So then only they can be suggested for usage.
Okay, so at least you have
if
helped to
it-
ease my hesitancy
uh,
in
if-
connection with the devices.
even okay, ma'am. Even if it releases radiation, that could be in the tolerate level only, I think.
Okay. All right, thank you. Any other questions? Okay, so I'd like to extend, on behalf of World Resources Webinars, a sincere thanks to our esteemed presenters. You have certainly enlightened us and made us aware of IoT applications, their uses, their benefits, and of course the challenges, how we can deal with them. And we appreciate your time. And I also would like to thank the participants. Some of them have left, but for those of you who have been here, we thank you for your participation. And if you have any other questions, you can email the presenters. The link to the presentation will be posted on the World Resources webinar website. I would like to remind you to fill in the attendance form. The link is in the chat with the name you would like on your participation certificate. And if you haven't done that yet, you can copy the link from in the chat. So you're very welcome. And with that, I'd like to thank Dr. Krishnan for, again, coordinating and initiating this workshop. He is on tour at the moment, but we thank him very much for the background work in coordinating everything with the presenters and with the platform and so on. So do have a good evening and goodbye.
Thank you and goodbye.